My name is Daikoku from International Research Center for Neurointelligence in the University of Tokyo. I talk about a computational study on musical development. The theme is depth and the uncertainty of statistical knowledge on musical creativity fluctuate over a composer's lifetime. First of all, statistical learning is a learning mechanism that is innate in the human brain and contributes to language and music acquisition over the development. Within the statistical learning framework, the human brain computes transitional probability of motor and sensory sequences, grasps the transitional probability distribution, and predicts a future state to minimize sensory reaction and optimize motor action. Through statistical learning, the brain generates a statistical model of sequential information and optimizes it over development and own experience. In the end, humans become able to produce the structured information such as music composition. Through such statistical learning process, human is motivated in optimizing the internal statistical model by uncertainty resolution, which has been regarded as rewards. Humans' behavior, however, appears to be not necessarily directing to efficiency, but sometimes inefficiently behave in order to explore maximum rewards. Such inefficient behavior can often be interpreted as novelty-seeking behavior and objectively evaluated by using entropy in the information theory. This entropy has been regarded as uncertainty. Together, although brain generally minimize uncertainty of music structure, we sometimes derived pleasure from uncertain musical event by a novelty-seeking behavior, by which we anticipate maximum uncertain resolution. Few studies, however, investigated how such novelty-seeking behavior can be observed in musical composition. The present study investigated how the statistical musical model and its uncertainty fluctuate over a composer's lifetime. To investigate, this study used Piano Sonata by Louis van Beethoven. His compositional career is often divided into the early, middle, and late periods. It is believed that he always explored new directions of musical composition and gradually expand his scope of music over his lifetime. Using Beethoven's Piano Sonata over his lifetime, the present study examines time-course variation of two types of statistics in music. That is, transitional probability of sequential pattern that appear in all of the piano sonata, and entropy of whole transitional probability distribution. It was hypothesized that phrases that frequently appear in the early period might decrease in the late period, whereas entropy might increase in the late period, possibly due to novelty-seeking behavior over his lifetime. The Piano Sonata by Louis van Beethoven was used in the present study. Using a score writer, electronic score data of the sequence of highest pitch were extracted from the XML file. The representative example was shown in Figure 2 of this slide. Using all the sequence of highest pitch, sequential pattern based on uni to 4 grams were extracted. For each type of the sequential patterns, all pitches were numbered so that the first pitch was 0 in each transition and an increase or decrease in a semitone was 1 and -1 based on the first pitch, respectively. The transitional probability of sequential patterns were calculated based on zeroth to third order Markov chains. Then, the information content and conditional entropy were calculated based on information theory. Here is the results. The results agreed with my hypothesis. That is, in the last period of the composer's lifetime, the transitional probability of sequential patterns that ubiquitously appear in all of his music were decreased, whereas the uncertainty of statistical model were increased. Further, these findings were prominent in higher rather than lower order model. This may suggest that higher order statistical model is susceptible to experience and psychological effect over the composer's lifetime. In sum, the present study detected time course variation of predictability of familiar phrase and musical uncertainty. According to corpus study, the historical characteristic of music can be extracted based on the error. This indicates that strategy of composition and musical knowledge depends on error. The present study also suggests that characteristics of music can be extracted based on the period within a composer's lifetime. In addition, the higher order hierarchical structure showed larger time course variation of both predictability of familiar phrase and uncertainty of whole music. From the psychological perspective, it would be interesting if the higher rather than lower order statistical knowledge was susceptible to experience and novelty-seeking behavior. It is of note, however, that the present study did not directly investigate the composer's statistical knowledge of music, as only the statistics of musical score were analyzed. Further, the present study only analyzed one composer, therefore could not discuss universal phenomenon on statistical learning. This suggested that there may be other possible explanations for the finding of the present study. Nevertheless, the present study first demonstrated that uncertainty of statistical knowledge on musical creativity fluctuates over a composer's lifetime. Thank you for your attention.